Thank you very much. Thank you. And good morning or good afternoon, depending on which coast you are at. My name is William Cheng. First of all, I would like to acknowledge that I am joining this workshop from the UBC Vancouver campus, which is on the traditional, ancestral, and unceded territory of the Musqueam people. And thank you again for the Fisheries and Oceans Canada to invite me to join this very important and timely workshop. In my talk, I will provide an overview of some of the key challenges that climate change brings to marine capture fisheries in Canada and relate that to relevant adaptation options. I'm drawing many examples from the works that my groups or I was involved in because I know the works better. However, I acknowledge that there are many other research on the topic conducted across Canada and in other parts of the world by colleagues. Many of those works are conducted by colleagues that are also in this meeting. I would be really it would be great to continue that discussions with these colleagues in the workshop. Oops, sorry. Okay. As you know, marine ecosystems are very important for people and in terms of food, livelihood, culture, and as well as climate regulation. However, the intensifying climate change is threatening marine biodiversity as well as the essential ecosystem services that they provide to us. The Intergovernmental Panel on Climate Change, which is a global panels that are tasked to assess the latest science on climate change, highlight that the ocean is warming, it is losing oxygen content. Marine ecosystems are also facing the threats of ocean acidification, sea level rise, and increasing frequency and intensity of marine heat waves and other extreme events as well. In addition, the ocean is being threatened by other non-climatic human stresses, including overexploitation, pollution, habitat loss, and invasive species. To give you a sense of what Canada oceans and the animals and marine life, as well as our fisheries are facing, this is a figure that shows the observed changes in sea surface temperatures across the 3 Canadian oceans. It shows that the oceans are warming rapidly, or have been warming rapidly in the last century, especially in the Arctic. In the last half century particularly, we have observed that Canadian oceans have warmed by around 1 to 2.5 degrees Celsius, with the Arctic warmed almost double the rate of those in the Pacific and Atlantic coast. These also include, for example, other changes in the oceans, for example, in the Arctic, decrease in sea ice extent. And these changes are affecting fish stock fisheries, as well as the people, human communities who are dependent on these fish, on marine ecosystems and fisheries. And in order to understand the vulnerability, risk, and impacts, we really need to understand and put into context the interconnections of these different human and natural components and their dynamic interactions in the context and in the understanding. At a very high level, the ocean actually is already absorbing a lot of heat as well as carbon dioxide. It's estimated that it has absorbed around 23% of the emitted carbon dioxide and over 90% of the heat from human activities. So without the oceans, our Earth would not be livable. But in doing so, doing this kind of very important climate regulation service for us, the ocean is also changing. It is affecting fish stocks, fisheries, marine biodiversity. And changing biodiversity also then affects the benefits that the ecosystem brings to people, as I mentioned, food, livelihood, and culture. While human activities around fisheries would also affect marine ecosystems through various human activities such as fishing or introducing new species to it. At the same time, changes in marine ecosystems also affects its ability to mitigate and adapt to climate change. So again, it is very important to take the human natural systems in the context when understanding risk and vulnerability. And starting from the animals, we know that marine species are really sensitive to the changing ocean, particularly changing temperature, oxygens, and other ocean biogeochemical changes. We know that marine fish and invertebrates and shellfish, they are adapted to a particular environmental temperature that they live in that environment. And when temperature increase or decrease from that temperature, their body functions decrease, their performance decrease, that affects their growth, reproduction. And when temperature increases to a certain extent and it's sustained for a longer time, the fish may even die. And these impacts of ocean warming are also exacerbated by other ocean changes, including ocean deoxygenation and ocean acidification for some species. And with that in the context, it is then affecting the individual species. Impacts by climate change are affecting the bigger context of the distributions of species, the abundance of species, as well as the structure and community compositions of the different species in the oceans that then affects fisheries. To illustrate these changes, this schematic diagrams shows the red circle is a distributions of the fish stocks, for example, for halibut. And when the oceans warms up, the fish will be affected, as I mentioned, but then they also would respond to that by the changing oceans, warming oceans, by changing their distribution, so that they would find more waters or reestablish in waters where the environmental temperature are more suitable for them to live. And so, as a result, it would lead to a shift in distributions of the species. In many cases, it is towards the high latitude regions. So in Canada, it's moving towards the Arctic, or for some of the fish, also move to deeper water, where they can find a cooler area that are more suitable for them to live under a warming ocean. But then it means that there's area that the species will decrease in abundance and may even be locally extinct in that area as they move out of that distributions, while the species may invade or move into new area where it does not, it did not occur in recent past. But then it then have implications for a number of things that are related to management. First of all, for spatial management, when species shift their distributions, it really affects the effectiveness of a certain spatial management tools, such as protected area, in conserving or protecting a certain species. At the same time, when fish change their distributions, they do not need a visa, so they don't need to respect political boundaries. So in this kind of shift, it may create a shift in resources distributions between countries or jurisdictions that leads to challenges to transboundary fisheries management. And I will give you a little bit more scientific studies looking into this aspect in my talk today. And the thing is that these are not theoretical. It is already happening. It shows up in observations by scientists, by also stakeholders, by fishers, and by resource users. And for example, the IPCC, Intergovernmental Panel on Climate Change, assessed the latest science about some of these changes in the oceans. What they conclude is that the ocean is already changing in Canada and in the world. In this case, it includes the latest knowledge that are assessed by the IPCC for that talk about changes in globally or in North America or in the Arctic. It shows that there are many studies that shows that the marine ecosystem is already shifting in ecosystem structure. The species are changing their distribution range. The biological timing, what we call phenologies, are also shifting. For example, the migration pattern timing or the reproductive timing. And that also affects the fishery use and aquaculture. And that many of these evidence are consistent in directions for shifting ecosystem structure, changing range shift, and timing of the biological events. While for fishery use and aquaculture productions, there are both positive and negative evidence for both globally and in North America, while in the Arctic, the evidence so far is more negative. And one of the changes that we have indicated and find which is very widespread for fisheries in Canada as well as around the world is the changing species compositions of the catches. This is an example of a study that we did. And we look at fisheries catches. In this case, the figure shows the changes in catches in Pacific Canada. But the work that we did was global, so it includes also other parts of the world and other parts of the oceans in Canada as well. And basically, as the oceans warms up, the species composition changes accordingly. On the figures on the left-hand side, you see bluefish and redfish. Bluefish is a cold water species, while redfish is more warm water associated species. And as oceans warms up, then the dominance of warmer water species increase. And this is indicated by an index that we developed called the mean temperature of the catch, which is the average of the preferred temperature of the fisheries catch in each year. And in Pacific Canada, there's a strong increase since the 1970s. That significantly related to the changing ocean temperature. And that what it means is that we are already seeing and detecting an increasing dominance of warmer water species in fisheries catches in Pacific Canada. And that's the case even we account for the effects of fishing and in changing the species composition. And the thing is, it is not only affecting the fish in the water or in the fisheries, but it is also affecting the species that are served on plate in our table. In this particular study, we look at seafood menu, so menu that are served by seafood restaurant in Vancouver. And we obtained those menus that date back to the 19th century, so a long time ago. And we try our best to identify the species that were mentioned in the menu, and then use the same methods that I just talked about, identify the preferred temperatures biologically of those species, and then see whether there were changes in the kind of species that were served by the restaurant in Vancouver over this time. And what we find is that similar to the fisheries catch, restaurants in Vancouver are increasingly serving more warm water species, particularly in recent decades. And that changes also match up with the changes in sea surface temperature. And just to put it into perspective, we also look at menu in Alaska and California. And as we expected, Alaska are serving more colder water species, so the temperature of the seafood menu is lower, while in contrast, those in California, and specifically in LA that we look at, has a higher temperature of the seafood menu catch. So that really highlights that the changes are shifting from the oceans to fish stocks, to fisheries, and then to consumers. So, these changes are really affecting both natural and human system. And it is not only that the species composition are changing, the overall amount of catch that could be harvested from the oceans are also changing too. So these are really busy figures. I will highlight the Canadian part for this talk. This is a figure that is used in the published in the IPCC report as well, the special report for the oceans and cryosphere. And on the right-hand side, which I want to focus on to reduce the complexities, it shows the Canadian oceans, Pacific and Atlantic. The red bubble shows the observed changes in maximum sustainable yield. So it shows that in the last 50 years, maximum sustainable yield has decreased slightly in the Pacific coast, while increased in the Atlantic coast. That's based on observational data, based on fishery survey, and that's in the past. And then the background shows the projected future based on simulation models, basically 2 simulation models for fish and 2 simulation models for the ocean changes. And the direction of changes are quite consistent with what is happening in the past. So the projections are for the future in the 21st century under climate change. And so it shows that it is the same for both low and high emissions scenarios, with the high emission scenario showing a much bigger changes compared to the low emission scenario. So it means that it is not only changing species distributions, it is also changing the amount of fish that we can harvest from the oceans. Although the amount is much smaller compared to those in the tropics. If you look at the global map, the tropical waters really are projected to be impacted by climate change with a large decrease in catch potential. In Canadian waters, the impact is much smaller relatively. However, this doesn't mean that the impact is not projected to be big in the future for fisheries in Canada under climate change, because hiding under that small number of changes in the total harvest, there are lots of changes in species compositions. And this is the projections that we did for Pacific Canada and across some of the species that are important in the region. And particularly in this case, we look at species that are also important for coastal First Nations here as well. And this shows the projected shift in their distributions under climate change scenarios in the next few decades. So by 2050s relative to now, it shows that species are shifting their distributions towards high latitude regions for almost all of the species. And the high emission scenarios means a bigger shift as well. And these shifts then translate into changes in their potential fisheries catches because some of the species are moving out of the Pacific Canada waters, while some species may be moving in. So in this case, we look at both the effects on small-scale fisheries and the large-scale fisheries because they are targeting different species. They are also operating in different ocean areas. It shows that, for example, for majority of the species, there is a projected changes, a decrease in catch potential, except for a couple of species. And I want to highlight, for example, the California squid, which is a species that is currently not a major fisheries in any major fisheries in Canada, Pacific Canada, but it's projected to increase quite substantially into the future. And that really highlights both the challenges as well as the potential opportunities in terms of fishery resources availability for Canada. And in fact, these changes are also already happening. You may be hearing from news as well as from scientific studies about the shifting distributions of California squid, and that some of the squid populations are even expanding to Alaskan waters. So these changes are not only theoretical in our simulation models, but that is matched up with what we are seeing in the ocean. And some of the challenges are besides the challenge on the commercial fisheries, it is also affecting a lot of the small-scale fisheries, and particularly for fisheries harvested by coastal First Nations. And this is a study that is looking at that dimensions. We've looked at the potential catches from our projections for the 2050s for different coastal First Nations across British Columbia. And it shows that there are regional differences in those projected changes as well, with those nations in the southern part being projected to be more impacted compared to the northern part for the kind of food and ceremonial species that are important to them, such as salmon, herring, and halibut. And some of the changes are quite big too, like 30% decrease in salmon populations in the next few decades, or like almost 50% decrease of Pacific herring. And these changes are not only about the changing availability, but then also about the sharing of the resources as well. And in this case, it is highlighting the sharing resources between nations. So in Canada, we have a lot of shared fish stocks between US and Canada. And one example is Pacific halibut, where there is a Pacific halibut commissions that manage the transboundary fisheries of the species, of the fisheries. And we project in this particular study that these species will shift under climate change, and that it will really challenge the existing agreements between the countries in the ways that they are sharing these resources. And the changes is also being challenged, is also a challenging one because of the timing. And this is a study that we look at our projections and try to estimate the rate of change of these transboundary fish stocks. And we look at the time at when there will be new changes that haven't been seen in the past. So what it means is that if changes haven't been seen in the past, in terms of the changes in transboundary fish stocks, it means that it really challenged our ability to manage those transboundary fisheries management, because we basically are outside of our previous knowledge and experience. And in North America, across 8 fish stocks, transboundary fish stocks that we assess, we find that the average year when this happened, when we see unprecedented transboundary shift, is around 2035. I mean, which is actually around 10 years later from now. And we know that international agreements, discussions take a lot of time, and that so it really highlights the urgency of addressing these transboundary issues now, because the changes are happening, and that it takes time to adapt our policy to these changing transboundaries in this international discussion. At the beginning, the opening mentioned about heat waves and extreme events, and that's something that I think is also the really important factors to account for in terms of risk and vulnerability, because the changes that I've been showing is about a long-term shift in the conditions, but then there are years when and time when there are extreme temperature changes that are really adding the challenge to the already being changed fish stocks and the climate change. For example, these studies, again, we use our simulation modeling to look at different changes associated with a heat wave event similar to the extent that we have seen in the past. And what it shows is that when heat waves occur, is likely to affect the exploited species across the whole Northeast Pacific coast. And there are some species that may be beneficial, but then a lot of species will be negatively impacted in terms of their biomass, as well as in terms of the species distribution shift. And in the recent studies with some of the colleagues here, we show that from the observational changes, the evidence of changes are more variable. The signals are not too strong in terms of the heat waves affecting fish stocks and fisheries. There are some fisheries that are really affected, such as the snow crab that were mentioned, while some other species are not that much affected by historical occurrence of heat waves. But then this study highlighted moving into the future with climate change, the heat wave can be exacerbated, and that the impacts can be more obvious and bigger, and that it adds to what is being impacted already by the long-term climate change as well. So in terms of some ideas for adaptations, I won't go into exhaustive things about adaptation because it's such a big topic, but just to highlight that there are a lot of available adaptation options to adapt to some of the changes that are highlighted. And this is again from the IPCC report highlighting some of the marine and coastal nature-based solutions that are available already, that have shown demonstrated feasibility, demonstrated high effectiveness to reduce climate changes, as well as high confidence in solutions such as transboundary marine spatial planning, sustainable harvest, climate adaptive management, ecosystem management, habitat restorations. So those are all things that it is important to do anyway, even without climate change. So it highlights the issue, the benefits of these, the co-benefits of these options, that it can address climate change, providing adaptations benefits, as well as having all the other benefits for sustainable fisheries, for marine conservation. Just an example, when we develop these management and adaptation options, we need to think about climate change. We need to make it climate proof or climate adaptive. For example, we know that many of the fish stocks in Canada is currently underperforming. Many of it are still considered to be below sustainable level. The Oceania every year published their annual audits that highlight these challenges and fish stocks around Canada. So there are already plans and an initiative to rebuild many of these fish stocks. But then in our study, we find that these rebuildings if we don't account for climate change, it really affects its ability to achieve its stated objective in restoring fish stocks. It shows that one way to help them achieve the objective is to really increase the level of ambitions in rebuilding the fish stocks, much bigger reductions in the fishing effort in order to rebuild the fish stocks back to the historical level. And this is just an example to illustrate that when we develop sustainable fisheries management or marine conservation plan, we need to add the considerations of climate change, because otherwise, even the things worked in the past or now, it may not work in the future. And there are also a lot of spontaneous or locally initiated adaptations that are being that are occurring all along the coast, and this should be supported as well with various resources and policies. So, for example, we have been working with the Haida Nations in Skidegate, looking at some of the climate change challenges and also supporting their initiatives in climate adaptations. And one thing that we identify is the potential of emergent species that may favor warmer waters in the future. And so these provide kind of opportunities that they are thinking and actually doing some of the knowledge capacity buildings in trying to be prepared for these changes in the future, so that they can secure the seafood harvest as well as for all the benefits that they can get from those harvests. So, in general, the potential adaptation strategies would include timely and easy accessible information and knowledge on climate risk, impacts, and response options. It really needs foresight, so preparation of governance arrangement across boundaries and both as well as within the jurisdictions of Canada under climate change. And it needs a participation from stakeholders so that there are coordinated local efforts, regional efforts, as well as the federal efforts. And there are also barriers that needs to be overcome in order to be successful in adaptations. That include financial, technological, institutional supports, as well as the need of managing all the other non-climatic human stresses that have also the co-benefits of ensuring sustainable oceans and biodiversity conservation. So with that, thank you very much. Again, this is just a snapshot of the big topics about risk, impacts, and vulnerability. I look forward to discussing more about this in the workshop with many of you. Thank you very much.
Thank you, Dr. William. A very informative and a fantastic opening as a keynote presentation. We appreciate it very much. Thank you.